Hello. Today we'll be quickly going over the 2017 AP Calculus BC Free Response question number 2. So, as it is a FRQ, we're going to try to keep it under 15 minutes for the actual solving of it. Maybe with some explanation I might go over, not entirely sure, but yeah. So, let's start it. The figure above shows the polar curves, r equals f of theta, and that, and then we have r of g of theta. R equals g of theta. So this one is f of theta, and this one is g of theta. And this is only in the first quadrant. So R be the region in the first quadrant bounded by the curve R equals f of theta and the x-axis. So this would be this region right here, as this is f, and that obviously is the x-axis. And then let S be the region bounded by the curve f of theta and g of theta, which in other words, and the x-axis of course, which would be this region. And it's not to be confused with this and this region, simply we just highlighted. Okay, so first, we'll just say S and R. And okay, so firstly, we need to find the area of R. And we're also going to note that this is a calculator. We need a calculator for this, so I have my calculator here. Okay, so we need to find the area of R. And this one is actually pretty simple. So the only thing we need to do is, one, note the polar equation formula for area, which would be the area is equal to 1/2 the integral from theta 1 to theta 2 of r squared d theta. And that's simply it, very simple. So we're going to obviously want to use this idea, and we have to decide what we want to do. Is there anything we want to subtract? Is there any limitations that we need to incorporate into this formula? And what we're going to find is that, well, it's only this area right here. And there's nothing we have to subtract. It's literally just the curve f of theta. So all we're going to do is 1/2 the integral. Note that we're using the first quadrant, so we'll go 0 to pi halves of f of theta f of theta squared, obviously, d theta. And that is that. Now, obviously, we have to solve this, so we're going to do 1/2 integral 0 to pi halves again, just rewrite, and we're going to, actually fill in the values. So it would be 1 plus sine theta cos 2 theta d theta, and of course I keep forgetting the square, but it's obviously there. And that would be the equation we need. So we're going to plug this into the calculator, and what we will get is that the area R is equal to 0.648. And that would be our answer for part A. Okay, so now let's look at part B. So we have an array where theta equals k, and that's in the first quadrant, seen by this. There, it's in the first quadrant, and divides S into two regions of equal area. So if we wanted to quickly see what that would look like, we would probably have something here, and it would just divide this, whereas this is equal to this. We're going to get rid of that confusing illustration, but that's the idea. And we have to note that we are not actually solving this, we are writing an equation. So what we can say is that we're going to essentially create two parts. I'm going to redraw the line here, pretending that makes two equal parts, where we have an S1 and S2. And because of this, at an angle theta, so at theta, S1 is equal to S2. Now, we are going to use this formula once again, but obviously we need some limitations because it isn't just the area from this curve to the x-axis, but it's the area to the x-axis minus r. So some a little bit of limitations, but it's fine. So what we're going to do first is we're going to find the area of S. And the area of the region S is equal to 1/2, just simply this formula up there, the integral. We're going to keep it in the first quadrant as last time. And now this is when it gets a little different. So we're going to do a nice square brackets. And as we said earlier, if we just wanted the area of g of theta, this would be this entire thing. So, I mean, that's close, but that's not what we want. So what we're going to do is we're going to take this entire area, and then we're going to subtract this area right here. And what we'll be left with is this one, which is exactly what we want. And the way we can write that is by using g of theta minus f of theta, all squared. And that is not right. What we actually need to do is, it's not all squared, because then that would be, different. It would just be each of them squared, because this is also written as the integral of r1 squared d theta minus the integral of r2 squared d theta, which is not equivalent to r1 minus r2 squared. So that's my bad, but we're good. So this is the area, obviously. Of course, we forgot the d theta, but that's the area. So what we need to do now is write an equation to find the two subregions at an angle k. So this isn't going to be too difficult. Essentially, what we can say is S1 is equal to 1/2 from 0 to k of the same thing, g of theta squared. I'm going to add that in a second, minus f of theta, both of them obviously squared like last time, d theta. And as you can see, the only difference is that this one goes from 0 to k. Now, for the other one, S2, we're just going to say essentially the same thing. I'm going to copy it for time's sake. Wow, that's weird. Almost matched up. S2 equals this, and the only difference that we were saying is now it starts at k, and then it goes to pi halves. And again, a way to think of this is simply we have a ray from here, we call this angle k, so we're finding this area, which is actually this big slice minus this little slice, leaving us with this slice. And then we do the same thing with this part. So we're essentially dividing into two halves, as it kind of hints at, and then we're but we don't actually obviously know the angle k. That's the whole thing. It's just leaving it symbolically. Now we actually have to write the equation. So what we'll say is a simple make it a little more room. 1/2 the integral from 0 to k of g of theta squared minus f of theta squared d theta is equal to 1/2 the integral from k to pi halves, and the same thing, g of theta squared minus f of theta squared d theta. And that is our answer. I don't want to box that up, but that's the answer. Okay, moving on. C. So what we want is for each theta in the first quadrant, 0 to pi halves, let w of theta be the distance between the points with polar coordinates f theta, comma theta, and g theta, comma theta. Write an expression for w theta, and then find wa, which is the average value of w theta over the interval 0 to pi halves. Now, okay. So for this one, it's not too complex once you figure out w theta, and it's the distance between 2 points with the polar coordinates, as we see. So simply what we're going to do, think about it this way. Let's say our polar coordinate, we're at an angle theta, which essentially means like, right here. So this would be, make it a little more clear, this will be f of theta, and this will be g of theta. And what we can simply do is, I'm going to erase that, but what we can do, and I'll write down here, say w of theta is equal to, and we know that the g of theta is the outside curve, I guess. And we'll say w theta is equal to g, I guess maybe we'll color code it, g of theta minus f of theta. And I mean, the reasoning behind that is simply like a, let's say the Cartesian plane, and you have 2 points, or 2 lines, rather. Now, the distance between the points at, say, 4 would simply be, this y1 minus y2. And it's the same concept here. So let us use this. We're trying to find WA now, W sub A. And that is a W. Yeah, that's a W. Okay. I don't know if it was a Greek letter, but it looks like it's W. Okay, so this is the average value. And what we need to do for this is a simple calculation using W theta, obviously. Now we have to note the restrictions where this is in 0 to pi halves, first quadrant, as we know. And, so what we do is find the average value of W theta over the interval 0 to pi halves. Okay. So what we need to do for this one is simply 1 over pi halves minus 0. And then we multiply that by the integral from 0 to pi halves of our W theta d theta. Now, the reason behind this is a simple, you can alternatively write this as the integral from 0 to pi halves W theta d theta over pi halves. And that's just like obviously mathematically that's the same thing, it's just a conceptual thing. Now, these clearly relate to our intervals. These are intervals, and we're subtracting them. And it's a simple, if you want to find the average rate of change, you would use y2 minus y1 over x2 minus x1. It's a similar idea where the change is represented by this, and then we have, the difference in our x coordinates per se, but now it's theta, obviously, represented by just a simple pi halves because it's from 0 to pi halves. Now we're going to write this, or put this into our calculator rather, and the answer we're going to get out is a 4.85. Okay, last problem. So now what we have to do is, using information in part C, find the value of theta for which W theta is equal to WA. W sub A is the function W theta increasing or decreasing at that value of theta, give a reason. So the first thing we need to do is we need to find the value of W sub A. Well, we have the value of W sub A. We need to find the theta at which that is equal to. So, that's a really simple thing. And all we need to do is say our W of theta is equal to 0.485. And that's, I don't know, it's not very complex. So then we will also say, we're going to expand this and say G of theta minus F of theta is equal to 0.485. And if you're going to solve this, because I guess you can also, I'll write it. You can also go further, obviously, and we can say we have 2 cosine theta, 2 cosine theta minus 1 plus cosine theta, sine theta, cosine 2 theta. Okay. 1 plus sine theta, cosine 2 theta. I'll just double check that real quick. Yeah, looks right. and this is equal to the same thing, obviously. Now, again, we're going to calc, and what we'll get is that theta is equal to 0.518. So, I mean, that's part of our answer, so we're getting closer, but we're not there yet. Now, what is the second part? Find the value of theta, so we did that, that's done, at W of A, one again, did that. So now we have to find, is it increasing or decreasing? And, we're going to go back a little bit into the year, but, I mean, we can still do this. What we need to do to find if it's increasing or decreasing is simply take the derivative of W of theta. So what we'll say is the derivative of W of theta, or I guess what we can really say is if the derivative of W theta is less than 0 at theta equals 0.518, it is decreasing, and we'll just go dot dot dot, vice versa. So that's, what we need to remember in our minds, but now we actually need to solve that, so we'll calculate W of 0.518, plug that into the calculator. What we'd get is a negative 0.581. And now we can use simple math jargon because we can note that it is actually, less than 0. So we can say since W of theta, the derivative of W theta at 0.15 or 0.18 is less than 0, then W of theta is decreasing at theta equals 0.518. And that would be our answer. That would be the end of this AP problem set. So I hope that, clears things up at all. And looking at the time, we were just over 15 minutes. This problem wasn't very difficult. I probably spent a little bit too much time explaining things. But yeah, so I hope that helps a little bit, and see you next time.